shipping our product across the world. We have an office in Abu Dhabi, an office in Tokyo, office in Washington, D.C., and in Utah. We're a deep technology company, so everything you see here was built by Florida. The drone, this radar. This is the secret sauce. This drone is guided by radar. Think of radar-guided missiles. This drone works day and night. It'll capture enemy drones day and night in the dark around your facility. Our company builds the radar, the hardware, the software. It builds the C2 system, command and control, that monitors the airspace around your facility. And we build the drone hunter from the ground up, and all the triggering mechanisms, net guns, etc. It is a complete end-to-end system to detect and defeat drones that are threatening your facility. We're winning. These are, in the press. The large orders in Japan, large orders to law enforcement across the world. Integration with DAS21. DAS21 is what the U.S. Army uses to protect Army bases. So Drone Hunter is an option to be used to protect bases around the world from drones intruding over their fence line. We just want to deal with Parsons, $1 billion deal, where we're part of the team protecting Air Force bases across Europe and Africa. This is real technology deployed today. What you're seeing here on the stage is the world's premier autonomous flying robot. You can set this up at night and come back in the morning with a pile of drones. It is completely autonomous. There's no human in the loop. You can put a human in the loop, but there's no human in the loop required to fly this. It is radar guarded. It will patrol the airspace and remove drones from that airspace. Toshiba made a large partnership. Pleased to announce that Toshiba is going to paint this Toshiba red and sell it under their label as well next year. Very exciting for our company. We put Boeing's name up here. Boeing invested 2 years ago. They spent 50 people, 8 months, doing a due diligence in our technology, and we were chosen by them. A substantial part of Florida. We're pleased to have Boeing as our partners. And those here in the Middle East, Mubadala, the sovereign fund of the UAE, they've also invested in the company, seeing the magic of this technology. So, we wrote a white paper that we can give you. Come up here and grab it, talking about our Skydome product and how it works with the drone hunter to protect the site. This is a white paper on an Army base, so you can grab this after the show and see how it's done. A lot of the lessons learned in there and how it all works. It's also a portable system. A lot of people take this with a mobile force or to a small event, a concert or something. It's completely portable. Why is this happening today? Well, we all know when we fly, we have pilots and airports and airlines. But what's going on is everyone's becoming a pilot, every neighborhood's becoming an airport, and every enterprise or household is becoming an airline, right? Drones are democratizing the skies. They're proliferating. Everyone has one. This is not just military against military. This is, lone wolves, different actors that want to do criminal behavior. Or even these people have access to these drones. The FBI, Christopher Wray, said a drone attack is imminent in the United States. It's coming to America. It's a big deal in Japan right now. Everyone's well documented what happens in the Middle East with drones, but it's coming to America as well. And this was an NFL stadium, the San Francisco 49ers. This is Kathy Lanier, the Senior VP of Security for the NFL. They had a drone come and buzz their stadium, created lots of problems. We've since gotten to know Kathy pretty well. Now let's move on to topics maybe more regional. What about these kinds of drones? And they're much larger, coming from a distance, not a small quadcopter. Are these drones coming out of China that anyone can buy on the Alibaba website for less than $1,000? This technology you're seeing at the show is not the purview. It's the purview of whoever wants to buy it off the internet. And that's what's driving our company's success and our deployments. You follow? Tell your friends. It's important. It's important. These large, another example of large drones for sale. They can carry a 300-pound payload. The key threats are drones are shipping in volumes. Small drones are capable of long distances, even larger drones, hundreds of kilometers, flying autonomously towards your site. There is no operator to capture. These are coming from a long distance. All off the internet. 5G communications. Qualcomm sells a platform anyone can buy and program to do whatever you want to do. There's no export control on that platform. And there's multi-vector attacks. It's not just one drone. Most of the time it's 6 or 7 coming from different directions. And what's really driving our business is all of this is happening autonomously. There is no operator. So let's talk about the autonomous drone threat. These are scripted flights. They emit no RF, no controller or operator, criminal or terrorist drone of choice, and they're impervious to RF detection or RF jamming. So no longer can you just put up an antenna at your stadium, listen for drones, and then press the red button. Press that red button to jam it to make it go away or fly in a circle, right? Because these drones are not emitting any RF signal. They're bought at some store, taken in the basement, programmed on an iPad, and they fly on waypoints from Yemen to Riyadh. There's no operators. They fly right over that antenna undetected. Right? So you need to be able to detect it and stop it. That's what we do. We have, our disruptive technology is this tiny radar. So instead of one big radar pointed across the desert, like a Batman beam, you can see something far away, but once it gets closer, you don't see it anymore because of the field of view. We deploy these relatively inexpensive, small 2-pound radar that emit like a Boy Scout campfire, very safe in an urban environment, and we light up the sky. We know where everything is 24/7. There's an NVIDIA chip inside of this to do all the AI on the edge processing you need to understand bird versus drone, etc., and detect what's happening. We have another model that's a little larger, about the size of a laptop, to look long distance. We aggregate all that data so you have a complete view of everything that's happening in the sky. That data, then, if there's a drone coming in from a long distance, can cue this drone hunter autonomously, have it fly into the basket like a radar-guided missile, but the drone hunter chases whatever it's coming after. And that's what's driving our business, is it's insufficient today to just put up an RF antenna. It's insufficient. Fordham was founded not to go after compliant, clueless, careless, but we're founded to go after criminal and terrorist drones. So people buy our systems when they really need to protect something. The different options to stop terrorist drones. This is one, right? This is what comes to mind. Just get the gun out and shoot it. If you've ever tried to go duck hunting, it's very difficult to hit a drone with a gun. Very difficult. They had 10 soldiers, U.S. Army soldiers, lined up in a line. They flew a drone 25 yards away and 25 yards high. So they shot 1,000 rounds in this drone. And the drone threw 10 laps, 10,000 rounds. Those soldiers hit the drone 0 times. It's on YouTube. Very difficult to stop a drone with a rifle. So what do? I'm going to talk about our SkyDome system and how it's deployed. We have the detection capability with the radar. We have the assessment capability with our SkyDome software. and then the mitigation with the drone hunter. I'm going to show you some videos here coming up. They're pretty fun to watch. Here's one of them with the Fordham drone hunter, to give you an idea of how it works. So it's cute. Works day and night in all kinds of weather. Locks on like a missile. Autonomously flying. Gets in position. Decides when to shoot on its own. You can see the tether. How it captures it and tows it away. All of that's done autonomously. There's no human flying that drone, no human deciding when to shoot. It does fixed wings. We invite all of you to come to Utah to our flight facility and watch it in action. That's fun. So here's how it works. You put a tiny radar throughout your city or an urban environment. So you're lighting up the whole sky, not just a point beam in the clouds. So you know where everything is over your airport or wherever it might be 24/7. And so you detect that enemy drone. The software, working with the sensors, can figure out drone versus bird. So it comes with a complete C2 system. So it's turnkey right out of the box, or you can integrate it with an existing C2 system. So you're not buying a stovepipe system. When it sees drones, it'll give them a score through our AI threat aware software, an assessment. This one's given a substantial score. This one's given what's it called there? A severe score, like click. So if you only bought one drone hunter, you know which one to go after. It prioritizes the sites. The software creates these volumetric exclusion zones. And so you can prioritize, if you're multi-vector threat, what you go after and what you don't go after based on what assets you bought to protect your site. The drone hunter will launch out of a drone hangar that keeps it on the ready 24/7. Environmentally sound, trickle charged, ready to go. It looks like an air conditioner box on top of a building, nondescript. Drone hunter explodes out of that. If it's the AI on the drone hunter with the radar will figure out itself. If the drone is going after is smaller and slower, it'll go into an attack mode. The attack mode will shoot a small net precision. There's all kinds of AI measuring the wind and how to attack. Our capture rate is well above 80%. Well above 80% at 4,000 or 5,000 feet in the air. All right, so high range, well away from your venue, we detect and make this capture happen. It's not at close range, but it's right on top of you. If the drone hunter, it has a mode here called the pursue mode to scare it away, but usually most people go right into this attack mode and shoot the net. If the drone hunter figures out that the drone coming in is much bigger and much faster, then we have what we call defense points. The drone hunter will get between the incoming drone and the defense point and capture it with a much larger net and make that decision in real time in the sky autonomously. There's no human in the loop. You can put a human in the loop if you're a control freak, but you're going to screw it up. The software is much better, okay? The software is much better at taking care of all of this. And then the drone hunter tows it away to a safe, designated location. This is a 6th generation platform. Worked on it with DARPA starting 6 years ago. Been deployed multiple places. We shoot nets, we shoot other things. When we have an NDA with you, we can go through the other things that we can shoot. All right, but the nets show our precision. So we have multiple effector types, custom made in the US platform. Here's a drone hunter working at night. You can't see it because it's at night. Actually, I don't know what happened to the screen. But I have a video that's showing at night. Okay, we're gonna skip to a new video. This is a much larger drone that we're gonna take down, the ones that are in the news today, affecting US sites in Iraq and other places in the region. The Skydo system autonomously selects that last piece is so key. It's very easy for a drone quadcopter to go up quickly or sideways, maneuver. Very difficult when you talk to your PhDs to take this information back, to go down quickly. Right? It took a long time for us to figure out when these fixed wings are coming in at high speed and they dive, how do you go after them? The AI on this figured that out and it dives forward with them. That was all controlled by the computer and by the radar and the whole system to make that capture and attach a drone net. Here's a little bit about the hangar that I talked about. For those that are in the US, you know about the NBC Today Show. We were on the Today Show. This is so unique, capturing the imagination of the American public. You know, in a world where we talk about artificial intelligence, AI, machine learning, I don't see a lot of it at this show. This is all artificial intelligence, machine learning. We'll talk a little about that here in the next part of the presentation of the radar and how that works. It's completely autonomous. You don't have time when you're at a site and drones are coming in to react, right? The machines need to take care of that. Some of the lessons learned when you security professionals know you need to assess your risk assessment, establish roles and responsibilities, your policies, accountability. Then you select a platform. When you select a platform, it has to do these 5 things, and these are the things that we do. We detect, we understand the intention of the drone and what's happening. Based on the intention, we'll have the proper response, whether sounding an alarm, cueing a drone hunter, whatever it might be, recover and reporting. When we worked with Interpol, it's a great partner of ours, with sites around the world, they talk about having the right tools, threat, and evidence. This presentation is online, or I can mail it to you if you'd like, and you can read the details. This is Interpol's slide where they talk about how to deal with the evidence and the threat and the tool. The great thing that they love about this is it captures the evidence, it keeps the evidence for them. And it's safe in an urban environment, even in an airport. Interpol, I want to pass this on and give Interpol a plug. They have a framework for responding to drone incidents that's really good. So I can give you this information too at the end of the show. Interpol looks at not just the tools that you use for airspace security, but all the different integration and different types of things that they do on the police side of things for an urban environment. You know, they're important to consider when you're putting together a program to counter drones. We did an event with them at the Oslo airport, a 3-day event, a very complex RF environment, where we shot down drones at a live airport. That was pretty exciting to run the drone hunter at the live airport there in Oslo. And you can read about that online as well. So this is a deployed system, one that works in a real-world environment. Let me talk a little about the artificial intelligence. So all of you are probably radar PhDs, but if you're not, let me give you a little explanation. So Doppler is the measurement of movement. That's what radar does very well. And so me walking on the stage would be my Doppler. My hands moving would be my micro Doppler. So the micro Doppler of a bird is the flapping of the wings. The micro Doppler of a drone is the spinning, or of a prop, or nothing, right? If it's a fixed wing, there's no fuel. And so here is a drone flying with a 6-inch sphere. What the radar sees is the drone with a 6-inch sphere, and then the micro Doppler of the blades, just these white flashes. So the AI in the radar figures out drone versus bird. Okay? And so it knows to go after the right things and ignore the other things. Again, if you're going to set this up for an autonomous system, you have to have that kind of intelligence. And a 2-pound radar is it's just magnificent. This is the technology that drives the whole system. Everyone knows when you turn on a radar system, you get tons of false positives, and it's like completely useless data. What we do is we analyze that data in real time, AI on the edge, to look at what's happening with some very complex algorithms and what it's seeing in the movements. And based on these numbers, the AI can decide not just on that data that's coming in, but also the track. You see the micro Doppler of the track, the radar data. The machine learning is always learning. And so in our labs, when we train the system, we're looking at the signature information and we're looking at the track information, combining that, which gives us very powerful classification of what we're seeing in the radar. So you get a clean view. So when you take this back to your scientists and people that know about radar, we have worked very hard to eliminate the false positive problem that radar brings. Doing that allows us to deal with swarms. So one of the challenges of traditional radar is that you can only track 3 or 4 things at a time. This can track hundreds of things at a time, and it's distributed. And so you take one of these out, the other 100 are still working, digitizing your airspace. So there's a redundancy to the system. Also, you're seeing things at different angles. It is perfect to be swarm-proof in the future, to understand swarms and their angles and what's happening. You need small distributed AI processing on the edge, right? That is the beauty of our architecture, to be able to do that. So you're future-proof from your events. Okay? Let's talk a little about swarms. I'm going to send these slides out to anybody who wants them, but you can see if your attack is from a single drone, multiple drones, or an attack from a swarm. The command and control, the purpose, the connectivity is different for each of these attackers. So you need to work with a vendor that understands the threat, what the threat is now and how it's emerging. So you can have the technology to deal with that. And that's what we've done at Fordham. When you look at what needs to happen to stop a threat, you need to detect it, track it, classify it, identify it, and mitigate it. And then you can do the recovery and reporting. If you have a single drone, you can do it with these technologies. Same with a multiple attacking drones. Same as above, radar, optics, autonomous drone-to-drone, multiple effectors. When you get into swarms, there's a whole different detection algorithm that needs to happen. You need to have the processing power to do that you cannot do with one single radar in the back of a truck. You need the processing power of multiple systems distributed, aggregated together, distributed computing to be able to solve that problem. And that's part of our architecture and what we're solving for. So just in closing, the world is vulnerable from an air attack, just like that video I showed at the beginning. How do you close the door in the sky? How do you lock the airspace? That's what Fordham does, is it creates these volumetric exclusion zones in 3D, a mile into the sky, above your sights. With 1 meter accuracy, we create these fences. So if anything passes through that fence and radar, it kicks off a rules engine, and you know what's happening in your airspace. You can measure the intention, make a decision, and remove it safely by launching a drone hunter, and at least give a warning to people. So how do you lock the airspace? You ask, what are the odds of it happening to you, but what are the consequences? And that's my message today. Please take action. Thank you.